Okay, number one, find the values, the trigonometric functions. I'm going to start Pythagorean theorem to find the third side. You could do Pythagorean theorem. Maybe you also recognize that it's a Pythagorean triple. In the ratio 3, 4, 5, it's double that, so it's 10. You could do Pythagorean theorem to find that side, though. And then I've got to find all 6 trig ratios. Of theta. So sine would be opposite over hypotenuse, so it would be 6 over 10. I'm going to simplify that to 3/5. So then cosecant would be the reciprocal, would be 5/3. Cosine would be adjacent over hypotenuse, 8/10 simplifies to 4/5. Its reciprocal is 5/4. Tangent, opposite over adjacent, 6 over 8 is 3/4. And its reciprocal would be 4/3. Okay, number 2, we've got to do Pythagorean theorem. This is not a special right triangle, or sorry, it is not a Pythagorean triple. So I've got 6 squared plus x squared equals 2 squared of 13 squared. Most of the questions came on squaring 2 squared of 13. When you square this, you square the 2, since it's not in a square root, so it becomes 4. And you square the square root of 13, the square and square root cancel out, leaving you a 13. So you get 4 times 13, which is 52. So you got to subtract the 36 from the 52. And then the square root, we get plus minus 4. We know it can't be a negative 4, so we must have a positive 4 here. So set up our ratios. Okay, sine. So we got a theta, opposite over hypotenuse, 4 over 2 square root of 3. I'm going to jot that right here. Because as I'll have to rationalize this, but it's a good idea to simplify the 4 and the 2 first. That might make your life just a little bit easier. So it's 2 over square root of 13. Now, by the way, when I can reciprocate it right now pretty easily. Cosecant is going to be square root of 13 over 2. But now I want to rationalize that for sine, so I get 2 squared of 13 over 13. Now I move on to cosine, which would be 6 over 2 squared roots of 13, but once again it might be easier to simplify that first. Reciprocate it, square root of 13 over 3 for secant, so cosine would be 3 square root of 13 over 13. Tangent, opposite over adjacent, so 4 over 6 goes to 2/3. So cotangent would be 3/2. Now, number 3, we have tangent is y over x. So we'd like to find out what r is. I could make a triangle out of those and then do Pythagorean theorem, but ultimately I'm going to take square both the x and the y, add them together, take the square root of that. So I'm going to have the square root of 64 plus 25. So I'm going to have, what, I guess an 89, square root of 89. I don't think it's going to simplify, so that's my r. And so now I can do my ratios, sine, cosine. Don't need to worry about tangents, I already have that. And then I have cosecant, secant, and cotangent. Cotangent's just the reciprocal of the 5/8 that we were given, so 8/5. Cosecant and secant are going to be easier because I don't have to rationalize those. Cosecant is r over y, so that's square root of 89 over 5. Secant is the r, square root of 89 over x, which is 8. But then I've got to reciprocate those and rationalize them. So for sine, I'm going to have 5 square root of 89 over 89. For cosecant, or for secant rather, I'm going to, or for cosine, I should say, I'll have 8 square root of 89 over 89. Okay, now for secant, I'm going to erase this to give myself a little bit more room to work on this problem. I want to know what r is. Actually, sorry, I know what r is. Secant is reciprocal of cosine, which was x over r, so this is r over x. So I want to know what y is. So think about your formula. R is equal to the square root of x squared plus y squared. So I could square both sides. So 49 is equal to 9 plus y squared. So y squared is equal to 40. So we're going to square root 40. And square root of 40 is 4 squared. Square root of 4 times square root of 10, so it's 2 square root of 10. That's going to be our y. I already know what secant is, so I'll skip that one. I could do the cosine right away. It's just a reciprocal, 3 over 7. So now sine would be 2 square root of 10 over r, which is 7. Tangent is y over r, so 2 square root of 10 over 3. And so now I've got to reciprocate those. When I go, let me write over here, 7 over 2 square roots of 10, when I reciprocate that, to rationalize, you only have to multiply by the square root of 10 piece, because the 2 isn't a problem. We can leave the 2 there. I don't have to multiply it. So my numerator is going to be a 7 squared of 10. My denominator, it'll be 2 times 10, which is 20. And then for cotangent, I'll have 3 over 2 square roots of 10. So to rationalize that, I'll multiply by the square root of 10. So my numerator is going to be 3 square roots of 10, and that'll be over 20. Okay, number 5, find the exact values. This is just special right triangles. So this is the long leg, so then the short leg, we divide it by square root of 3, so I just get 3. And so the hypotenuse is double that, so y would be 6. Number 6, the short leg is 5, so x would also be 5 because it's in a hypotenuse. Or I mean, sorry, it's an isosceles triangle is what I meant to say. And so then take 5, that short leg, or the leg, times square root of 2, so 5 square root of 2 would be my hypotenuse. Number 7, y is, the short leg is half the hypotenuse on a 30, 60, 90, so y is 4, so x would have to be 4 square root of 3. Number 8, x has to be 13, so 45, 45, 90, so y is 13 square root of 2. Okay, and this one I've got to work backwards by dividing by square root of 3 to figure out what x is, so I've got to rationalize it. So I get 4 square root of 3 over 3. And y is double that, so multiply the numerator by 2, so 8 square root of 3. It'd still be over 3. Number 10, y is going to be half of the hypotenuse, so just square root of 3. And then to get the long leg, multiply that by square root of 3, so we just get 3. Okay, number 11. Stationary horse on a carousel travels 8 rotations. How many radians did the horse pass through? Well, each rotation is 2 pi radians, so 2 pi times 8 is 16 pi radians. Number 16, you're at Adventureland. Decide to ride the Storm Chaser. The ride takes you several revolutions counterclockwise, shown in the diagram. Find how many radians you pass through during the ride. So let's find out how many full revolutions. Or how many? Okay, so we start here. There's 1 full revolution, 2 full revolutions, 3 full revolutions, 4 full revolutions, 5 full revolutions. Now in that time, 5 full revolutions, that's 10 pi I've traveled. Continue around, there's another pi because I end up over here, so we're at 11 pi right now. I'm going to write this down. And we go a little further. Looks like if this is 40 degrees, 40 from 90 is 50. That's a 50 degree angle right here. Now I want to convert that to radians. So I can take and put the 50 over 180 times pi. Now 50 over 180, I can strike the 0, so it's 5/18. So I have 11 pi plus 5/18 pi. I want a common denominator. So I would like to convert my 11 pi to a denominator of 18, so I can have a common denominator. So I have to take 11 times 18, 198 pi over 18, and then over here I've got my 5 pi over 18. And so now I can add together 203 pi over 18. That's how many radians were passed.